What we're going to see is primarily some concepts related to how to deploy a simple web application. So what I took is I took a small, I was looking at some samples which are available on internet, but I think the sample, I think I will show this GitHub link also. I'm taking this GitHub link. So you can also look at this code here, this GitHub link. I'm just taking from what Google is offering here. So this is very there are a lot of examples are there. So I think these examples they all also upload all these things in GitHub also. So this is a good place to look at Google Kubernetes engine. So this Kubernetes engine samples again this one GCP, but I think it is nothing specific to. All these configurations that I mentioned is applicable even for on-premise Kubernetes setup also. So concepts are the same because Kubernetes is a concept is a generic concept. So, but a lot of examples are there. I think this to start with, I think we can look at this Hello World app. But I think slowly we can add more complex. This gradually increases the complexity in this. I think also this guestbook is a multi-container and multi-service project where there is a front end, there is a back end, there is a Redis component which acts as a backend, and there's a API component. So UI, API, and DB. So DB here it is used as Redis, but yeah. So, but again, we have a lot of other applications which talks about how to manage the networks, load balancing stuff. So there are a lot of interesting components. Everything is whatever you think a complex application would be there. Everything is covered in this. So this way you will get a good understanding of how to use this. Kubernetes for any complex applications, right? And also it has some advanced concepts to even add storage. You can also from Kubernetes we've not covered the storage part. We covered the networking, but you can also add storage persistent disks also to your as a storage volume, so you can associate that. So and also multi Windows version, multi architecture components, everything is there here. So yeah, probably let's start with simple. So and slowly we'll move on. So I will take the simplest component, which is a Hello app. So it is a simple. It's a Go-based application, Go language. But I think we don't have to go to the technicals of this development. But I think at the end, what you need to know is it is exposing a Hello endpoint / Hello. Once you invoke the / Hello endpoint, it prints a Hello world. Okay, and it prints this our version as 1.0 and host name as, and also the host name of the laptop of the node. So this is when you hit this endpoint, this is what you should get as output. The simplest application, but we will gradually grow from here. So with this, of course, this is a Docker file is also there. Assuming that this could be any technology. It need not be Go here, but you can also write in Java, or you can write in Python. But in this example, it is a Go-based application, and there's a Go Docker file that is also there. So of course, you need to the prerequisite for Kubernetes is to Dockerize your app, right? So for Docker, I think you have Docker file where you can. It is taking from a base image, Golang Alpine 1.8, and then it is copying your code Hello app, and then it is running it. So and Go install is like running your app. So yeah, and so that's all. And also you're exposing the port as 8080. So and then you're invoking this application. So this is the simplest instructions where you can this for installing Go, and this for installing your application. Yeah, that's all. So and also if you look at nothing much. I think Scaffold is a library which you can also use. This is nothing to do with Kubernetes, but I think this Scaffold is a product from Google where this is an alternative way of writing a Docker file. So you want to create an application. You develop an application and you want to Dockerize it. So when you have to Dockerize it, we have two options. Either you can use Dockerfile approach where you can write some instructions, or if you're not familiar with Docker commands, Google introduced a tool called Scaffold. So here the instructions, you don't need to know much about it. The advantage in the Scaffold is that this Docker file that you get is built on a lot of layers, um, and it all depends on how you write a Docker file. You should write an optimized Docker file so that the size of the image is small. Um, but there, people make a lot of mistakes in this process. I mean, everyone can write Docker file, but you need to ask whether it is an optimized image. Meaning, is the image that you generate is it optimized? It means size wise it is smaller compared to. I mean, you can also write a bad Docker file, which can you get the output, but the only thing is it will be huge. So to avoid all those problems, Scaffold is a tool that is already generated that is supported by Google, and by using this, you can also generate a Docker file. But you don't need to have this headache of of I mean, Scaffold will take care of generating an optimized Docker file for you. That is a tooling. So I think you don't know about that much, but I think I'm just telling you these are two ways that you can generate any Docker image from your application. Okay, so let's take this application and try to deploy it in GCP. So with this, I'm going to GCP. So in Kubernetes, yeah, so this cluster is already there. So as the first thing, you need to create a cluster. Just since it takes time, I already created it, so it's already there. So I just need to connect to this cluster. And I just need to connect this cluster so that way, it is the water commands that we give following this. It is talking to that cluster only. So I have some instructions. Yeah, I think what I will do is I will first download this. Basically, it is like I'm doing a clone of this directly onto this node, this cloud shell. So I'm downloading this code. Already exists. Okay. So I think I downloaded it already. Okay. So I will directly go to this Kubernetes engine samples. So and then hello world app. Okay. So this is what the file that we saw now. So we have Docker file here. So for any of your application, once you develop everything in local, first thing of course you need to either it should have a Docker file or it should have a scaffold YAML, either of these two. So let's use Docker file itself. So first thing is once you need to export this project ID so that we are going to use this project ID going forward. So basically, what I'm going to do is I will explain the high level steps. The steps that we're going to follow is first we will set up this project ID and then we'll do a Docker build. So and then we'll once you generate a Docker build, we are also parallelly pushing this Docker image that we generated to the uh, Docker Hub equivalent in GCP, which is container registry. So you're pushing your image to container registry, and then of course Docker images you run, and then you'll also you're also finally using this command, you're pushing this image to Docker registry. And then, of course, you create a deployment, and then you do the scaling operations and all this, and the horizontal scaling and stuff. So, properly, let's look at that. So, first, let's export this project ID. I'm echoing the project. Project ID is nothing but this team spider that we created. So that way it is there here. So this going forward now, we can use this project ID like this. So here, if you look here, Docker build command I'm just giving a dot, which means I'm asking to look for a Docker file in the current directory. So this is, and also I'm asking to create this image, the Docker image with this name. So, for example, if I Docker images, okay, is okay. So right now there is no Docker images which are already created. So when I run this command, basically I'm already in hello app folder. So basically it will look for this Docker file which is there in this path, and then it will do a Docker build. So if you look at here, it is now trying to create the image from the current file. So here I didn't mention the Docker file. By default, it picked up. So since I gave a dot, which means I'm asking to look for a Docker file automatically in the current path. So if it's not there, it will give a complaint. But since already there, it took that and then it started executing this Docker steps from the Docker file. So now if I type this Docker images, I should be able to see this image that got created. So, but if you also see, this also yeah, installed Alpine, which is required for, it's an OS component that is required, and also this is the Golang is like a Java. So like it's a programming language JDK that you need. Similar to JDK, you need Golang for Go applications. So I downloaded that. So basically your application, your language, and your operating system. So that is, these are three components that got downloaded. Yeah, this name is what we already gave when you asked to build this Docker image. So and also we asked to use version v1. At this point, the Docker image is built. So it is, but it's all there in this console. So now let's, of course, we can discuss this. Yeah, I think now we need, the next idea is to push this Docker image to container registry. So container registry is nothing but your Docker Hub equivalent. So either you can use Google's container registry or Docker Hub. So, but in this case, I'm using Google's container registry. So first, I'm enabling that container registry so that I can upload something. So I'm enabling it first. So with this, I'm enabling it, and then I'm also configuring the Docker as my default. I'm authorizing Docker to use this container registry. So I need to configure that Docker. So with this command, what it does is it creates a Docker in .docker file. It creates a config.json. So it will add all these entries. So which means the gcr.io or these are all container registries from container registry extensions from Google. So it adds all this container registry like US, Europe, Asia, staging, marketplace. I mean anything gcr.io or star.gcr.io will all use this Docker registry, and we're asking Docker to use this as our default registries. So that's what I did. So again, these two are Google specific stuff, nothing to do with Kubernetes. Now this is where I'm actually pushing this image to this Docker Hub. So gcr.io and I'm basically the image that we have, which is there in my local. So this image, I'm now pushing this into the Docker registry. So container registry. So before that, I will just go to container registry. Container registry is nothing but your equivalent to your container, like Docker Hub. So I just want to show you how this will look like. Container registry. Container registry is here. So here you can, it's nothing but then the repository of all your images. So at this point, this is empty. The container registry is not having any images. What I'm going to do now is to push this Docker image that got generated, Hello app, into this container registry. So basically, I'm storing all my artifacts of images here. So yes, so for this, the command would be to just execute this Docker push. Basically, I'm pushing this image to this container registry. So I'm actually just trying to push this image to this container registry. Okay, so it pushed it. So you should be able to see something here. Okay, so hollow is here. So going forward, if some other team, let's say tomorrow, wants to use this Docker image, they can directly download it from here. I mean, this is just pushing all your libraries in one place. That's all, just a repository. So yeah. So now your Go application at the end, at the another step, you created a Go application, and also you created a Docker image from it, and then you pushed it to the container registry. Now we have a Docker image ready. So now comes the Kubernetes part. So far nothing to do with Kubernetes. So we just pushed your Docker image into this registry. So now using Kubernetes, you want to deploy this application. So that would be the next set of steps. So now, of course, you can use this kubectl. The kubectl starts from here. So from what we learned earlier, right? So we just need to create a deployment, and then the image that you want to use is this image that you already uploaded, this container registry. So this is a container registry that if you want to upload it here. I mean, yeah, this image is what you want to use, right? So I'm now creating. This is Kubernetes specific. Just doing it here. Okay, so this is Kubernetes. Okay, this is, I mean, here if I see I'm not using the YAML stuff, I'm just using simple create a deployment command. I mean, as we discussed, we can do it in both, right? Create deployment command. Also, you can use a YAML approach also. But in this case, I'm not using the YAML approach. I'm using create command. So get pods, you see. So this hello app is now created. And also now we want to scale this stuff to 3 replicas. You can do that. Again, if you type this get pods, then 3 replicas are running now. And also you can also create a something called horizontal pod autoscaler, which is another component for scaling. I mean, in if you want to scale in Kubernetes objects, there are 2 objects. One is HPA, which is horizontal pod autoscaler, and also something called VPA, which is vertical pod autoscaler. So yeah, so horizontal pod autoscaler is basically you're scaling this application horizontally by in terms of increasing the CPU. I mean no, not CPU. I mean the number of instances. So based on CPU. So the CPU is 180%, for example. So you are increasing your instances with minimum is 1. Initially it will create with 1, but I think slowly as when the load is more, 80% CPU is hitting, then it will increase by 1. But the max is 5. So also you can keeping a max limit. So max it can load up to 5 instances. So I'm just doing this so that this rule is set. So now the deployment is now ready for scaling. And also now, of course, we need to call this hello world, right? So we need to expose this service. So I think here again, create expose deployment, and then follow this step. I think this is something we already saw. I'm just giving an overview. So expose deployment name, and then here we are giving what is the name of the service, and type is what we discussed earlier. This load balancer is you're telling that you're asking to create a load balancer. The port is 80 and the target port is 80. Right, so it is exposed. Now, if you apply this kube service, get initially it is pending, but probably at some point you get an X1 IP. So pending, because you can also see from here. Services and ingress, you can also see this, which is refresh. Still creating. And probably once it is created, you will get an OK here. Yeah, it is OK. So which means it is our endpoint of the load balancer, and we can invoke it. Okay, so this is your hello world application, so which is auto deployed here. So yes, so that's about simplest hello world application that we can deploy. So again, if you see here, the logical points, I mean, I'm sorry, I increase this version to 2.0, which is it's already deployed. Let's say if you want to make this to 3.0, you can just make this change, create one more deployment. For example, here it is main.go. You can also change this example version from 2.0 to 3.0 and deploy it. I'm saving it, coming out. And then, of course, you can follow the same steps of creating the Docker image from this hello world, and then you can deploy this version 3.0 also. I'm putting as V2. So it says the tag does not exist. Sorry, sir, I need to do a Docker build. Sorry, forgot that step. So I need to create a Docker build image. I'm just creating with another Docker build. So I made a change in this Go file. So now I need to do a V2. So it builds the same code. The new so now we see a V2 is also now created. So and now you need to again push this V2. Here, if you see Docker push your URL of your container registry, followed by what is, I mean, this is the image name and then the version details. So I'm pushing this V2 version. Okay, it's pushed. If I go back to your container registry, you should be able to see that V2 version. Container registry. Okay, so V2 is now pushed 1 minute ago. So, so V2 is pushed. So now you can deploy your V2. Again, you want to redeploy using Kubernetes, and again it applies a rolling update pattern. So I'm here. If you see here, I'm just giving this version as V2 here. So I'm asking to use this V2 Docker image now, which is this, not the V1. So it's now I'm asking Kubernetes to deploy this V2 Docker image. So and immediately if I type kubectl get to look at it, is trying to terminate the older versions, older version, and then try to deploy the newer version. So this is what I was referring as rolling update. So it terminated the older version and created the newer versions. So and yes, finally, of course, yeah, that's also nothing much. I think if you go here and look at your service now, it should come as 3.0 now. Yeah, it's 3.0, which is you modified your version before. Yeah, so that's about this simple Go application that we could deploy. So summary, what you need at the end of once you develop something, right? So you have an application, you develop a simple application. So first thing is you need to have the Docker files or scaffold YAML. So these two are required for you to do a Docker build. So 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 once and then you should create the image and then you should upload that image either to Docker Hub or the container registry that we have. So far those steps are nothing to do with Kubernetes. So Kubernetes work starts with assuming that your image is available somewhere. In this case, it is the container registry. So there, from there, your Kubernetes basic stuff starts. So yeah, so simple web application. So probably, I think, I mean, I'll pause here. Any questions in this before we move to some other application? Okay, let's move on to some. Yeah.
One thing, I don't
Uh-huh.
know, like a typical use case,
Mm-hmm.
you have shown Go application, very small application, right?
Right.
So just so let's say there is a existing C++ application, right?
Mm-hmm. Mm-hmm.
Which is a large footprint.
Hmm.
Can you still do it, or like, is it advisable or it's not?
Yeah, I mean, as long as there's a Docker image you could build, that is the only thing that is
Mm-hmm.
required. So as long as you could build a Docker
Okay.
image for a legacy app, which is C++ in this
Mm-hmm.
case, that's all. I
Yeah.
mean, it doesn't matter from there on. So
Yeah.
you could do everything in Kubernetes. Yeah.
Uh-huh. So one last question, right? Like, so I don't know how you do this, but so let's say this vendor application, right, provides a license, right,
Mm-hmm.
for that application, and it is based on the UUID of that machine, correct?
Uh-huh.
So because you are pulling in the images, Docker images, like say, let's have a Red Hat Linux, can you fake the? I'm just trying to push my problem there.
Uh-huh.
So can you fake that UUID in the Docker image? Just like
Yeah.
spoofing MAC address, right?
Yeah, I mean, if you see here, what you need while you create a Docker image is the Docker build command, and it generates an image. Once you do a Docker images, you should be able to see the image name, like how we saw here,
Mm-hmm.
right? So,
Yeah.
um, yeah, but I didn't get what is that UID reference that you're referring. So this is a Docker image name.
So
Yeah,
this is what UUID is, nothing but a unique ID
yeah.
based on the network address and the MAC address and other things, right?
Mm-hmm.
So I'm just asking, right? Like, when you can you like maybe it's is it possible when you kind of do the Linux image, or on top of the Linux image, if you can set the UUID?
Mm-hmm.
Maybe it's very deep technical, but I'm just trying to see if it is even possible, right? Like in container image, or so the basic question is containers. Though you have created an image, it runs as a process on the host machine, right?
Mm. Correct.
So you may have a different network ID, but
Mm.
just like your what do you call cell phone, you have a IMEI card number or anything, right? Just
Mm-hmm.
like that, every server has a unique ID, and they call it that as UUID,
Correct.
right? In containers, can you fake that? Okay, this is very means like a free question, but just trying to see if there is an answer to that.
Yeah, I mean, well, I mean, it is a process at the end. If you could make a process, I mean, it's nothing to do with the Docker or something. It is as long as you could fake some process in any operating system. Yeah, you could hack images also. The image is also a process at the end. Right? So, I mean, I don't have an answer to it, but probably, yeah, as long as you could fake a process in any operating system, you could do it. Docker is also nothing different. It's just a process. So,
Right, right.
yeah. So, yes, the answer is yes. Yeah.
Okay, yeah. So the problem is use case is this, right? Like right now, we are trying to struggling with hardware, right? Like we are trying to means like one server we have, but we have to run three different instances and of the same application. And container is the best way to do Dockerization is the best way to do that, actually, to give two three different things. But we have only one license, so it's
Yeah.
like Windows license we have, right? Like we just have one license, and we can't seem to kind of get more licenses. So it's the same. Uh, so maybe I'm thinking like containers or like Dockerization can come to the rescue. Just my wish list, but
Yeah. I
anything
think,
real.
yeah, that's true. I think, I mean, partly this, as you already mentioned, right, is just another process running. Yeah, so as long as you could hack a process, you should be able to do whatever you could do. So, yeah, it's nothing that Docker is solving the problem here. It's more what is possible to hack
No, no,
outside operating.
it is like your mirror image, right? Like, so Sham, I want 3 instances of Sham, and it should behave the same. So they each one thinks that I am the only Sham. That's the that's
Yeah.
the challenge here.
Got it. Yeah. Okay. Okay.
Okay.
Good. So yes, I think yeah. Before we move, I think any questions here in this process? I think we followed the simplest. We took the simplest use case and we tried to deploy it. So in terms of the process specific to Google, I think what is process specific to Google here is uploading it to a container registry and a Kubernetes engine, which is specific to Docker, which is specific to Google. But I think and the load balancer. So these are the aspects which are specific to Google. But I think the concept is same when you apply the same thing in any cloud or any on-premise setup. But yeah, let's go to some complex application. So with a multi-cloud.
Yeah. So
Yeah.
just one thing is instead of Google registry, Docker Hub is very famous. But Docker Hub, they recently put some limitations,
Yeah. Yeah.
throttling limitation. So that is because everybody is using it, right? So it's so free. So they want to commercialize that. So more and more people will start using a private registry going forward because of
Yeah.
that.
Yeah. Exactly.
Or they have to pay the Docker Hub.
Yeah, I think that's a very good point. In our organization, so we were using Docker Hub, but once this Docker Hub recently pushed this, added this limitations of this throttling limit, meaning you could upload anything, but only thing is when you want to download something, there is a limit. Beyond that, you can't download from Docker Hub, which means you need to pay for Docker Hub to download something. If you, for 1 or 2 instances, that's fine. But if you have multiple nodes, multiple times you want to download on a given day, so there is a networking upload download cost is also there. So the Docker Hub want to commercialize that aspect. So yeah, I think with that limit now everyone is pushed to use some other container registry because Docker Hub, which is free so far, is now adding some commercial component there. Yeah, so I think that way this container registry, yeah, if you're using cloud, any cloud, every cloud, for example, Azure also has a container registry. Even AWS also has a container registry, so you can use that. Or you can create your own container registries also. For example, if you're a Red Hat, there's something called QA, QUIA. It's also very popular. Uh, QA.io. So this is also popular for Red Hat specific enterprises. It's also a
But you have to
container.
pay IBM for that.
Yeah, of course. It is not free. Again, I'm just saying these are all outside cloud options. I mean, if you're not looking for a cloud specific, but it's a Red Hat cloud, for example. Yeah. So yeah. So that is one way. Or there's something called. I mean, uh, they also called JFrog, right? So it's also an artifactory, which is now they introduced. I mean, so far we were, I mean, in a CI/CD setup, right? So there is once you see a pipeline creates an artifact, you generally push to this artifactory. So this JFrog also is one popular. Now they also added a container registry also for this. JFrog, you can also upload a container registry also in JFrog. So yeah, there are a lot of options are there. I mean, it's not just one. There are multiple container registries that you could use. Yeah.
Yeah, Artifactory is the most popular now actually because they are the binary kind of source control, right? Like it's like you can store all the images in there.
Mm.
So all the big enterprise companies, they don't allow you to go to internet and pull any image you want.
Right.
So they kind of govern it by basing like first they would look into their own hub, and if you are getting any new image, it gets cached into this local artifactory.
Mm.
That's the way they kind of maintain or like reduce the cost.
So you're
Not
talking about
reduce
the JFrog here.
Artifactory generally. Like there was another thing called Nexus too, Nexus Sonatype. So that is
Yeah.
also another
Yeah.
That was mainly for Maven, but I think now they are also coming up with all this Docker containers and everything. Everybody picks up, right? So that's it.
Yeah. Right.
So we have to pay somebody, correct?
Yeah, nothing is free, man. Either you give your information or pay.
Okay.
Facebook, you think is free? No, it's not.
But they are having a face. That's it. That's the money, man.
Yeah. Yeah, that's true. I think yeah, there are there's nothing free here at this as far as I know, but probably I think Docker Hub was the free component, but now that limit was added there. So I think people move from Docker Hub to some private repository, paying some money from having private repository. But yeah, as I think most, as you said, Jnani said, I think the point is valid. For example, in production environments, in every enterprise, right, production, even probably in some more stage in higher environments. So generally, the internet is will be disabled on the servers just for security reasons. So basically, you can't download anything from even though you upload everything in container registries or something, so you may not be able to access that. But I think the for that I think a private repo would be a best solution. Every organization will create a private repo which is not on internet, but they will not expose it on internet. Probably within that limit of their IP range, that will be accessible. So they'll have a firewall in place so that this could be accessed within this IP range. So there will be a private repo, and I mean, just like your local Sonar or local container registry. So you can upload your container registry into this private repo at the end of it, and then you use that to download in production environment. So when you have to a full Docker full.
Yeah, but the question is, see, if you are a AWS shop, then you have access to your VPC within that container registry. But even PGE, they are using this JFrog. They are also using that. So that means they have to open up the outbound. Instead of the whole internet, they have to open to that particular. For example, if it is Sonar type, right? They have to open up the outbound to that. Then only they could able to download at any point, right?
Yes, yes. I mean that is one option, but what I'm telling is you need to have a Sonar type not on public cloud. So you need to have an on-premise setup, not on public endpoint. I mean, all is public endpoint, right? You have sonartype.com, so there will be sonartype.com, for example. So this is on public cloud running on port 8080. Right? So, but port 8080 will not be for sure opened on public internet. So you need to set up your own sonar type probably on some port on a custom port 5000. I'm just giving an example. So that you could access it. So basically, I'm talking about a local setup now. So not on cloud. I'm talking about a local setup. So and then you have a local setup and you could access that IP colon 5000. You get that sonar setup. So and then you'll
So
upload
Gnani,
your.
in your case, which one you are using? Your company.
There is two things actually. Like the New York capital markets is still using Nexus.
So Nexus means Nexus on your on-premise you're talking now, right?
Yeah, everything is on premise.
Okay.
So and then corporate, right? Like so, we have two IT arms, right? One is the capital markets, the other one is the corporate infrastructure. Anything else other than like even the ETL team falls under corporate thing. So they use Artifactory. That is pretty new. I don't think very soon both will be Artifactory. I think they will get rid of Nexus. Actually, they don't want to pay two vendors, so
Okay.
they will migrate as soon as they migrate from. Because I think Artifactory was meant for all this Dockerization. Basically, all this they were designed for that, right? And I don't know whether you remember this. GitHub, right? Like, so Git is also like there is something called Git LFS. So if you want to source control your binaries, right? Git doesn't do it well. Actually, it is really bad. So what happens is you have binary is not as compatible as text. You cannot store layers. I mean, it's like you cannot merge all the differences and other things. So underlying, they use Artifactory. So Artifactory provides that customization, like it stores that binaries correctly, and Git LFS kind of does a proxy mechanism to that. So that ecosystem, Artifactory works very well with this new ecosystem. Nexus is still yet to catch up. It was a good Maven repository. Like if you are using primarily a Java shop and you are just using for jars and other things, that was okay. But I think everything is now moving to Artifactory, and it is really more performant. So I think it's slightly cheaper too, maybe.
Yeah, that is true.
So
Artifactory is it the JFrog is Artifactory or is it?
yeah. That's a company. JFrog is a company.
It's a company, and one of their product is Artifactory. You see here.
Yeah.
JFrog Artifactory. Right.
So they were there even before the cloud era.
Yes. Yes.
So
And all
they've
this
been there for a long time.
Very long time. I mean, they are specialized in this Artifactory. They started with Artifactory, and slowly they added pipelines and X-ray, which is for container security, because all this are open source images that we generally use, right, for Java or Python or in any application for that matter. All this open source can prone for vulnerability scanning. So this is more of a scanning tool which scans your image for any security vulnerability, and then detects that. And of course, your distribution is primarily your it's like a scanned X-ray output will be pushed to a distribution, so that way it's like a trusted software. It's stamped, so you can use this for any of your feature references. And of course, this again. Okay, sorry. This container registry is also what we're discussing, where you can push your Docker images here. Then, so yeah.
So this will work for Python and everything also, not just for the Maven, right? This one.
Yeah, everything. It works for everything. Yeah, it's a universal Artifactory.
Okay.
Even Nexus also works, but I think this pipeline, maybe they have a different X-ray mechanism. They have something else, but I think they're just slow to catch up. That's all it is. I think that's all. Maybe they are very close to Artifactory now, but
yeah. Right. So yeah, I think this discussion of generally the process in a CI/CD setup once this application works, right? So the CI setup would be that you should the prerequisites are you should have some Docker repository, so Docker repo. You can decide that of course you need to push this Docker repo Docker images there. So you need to have a Docker repo. Of course, maybe if you're a bigger company. Yeah, you should also need to look at an Artifactory. I mean, you need to Artifactory is like maintaining stable releases. For example, you have let's say every month you have a production release, right? So you have version V1, V2, V3, like this. Every production release you have a release. So you want to store
was it there even before the Dockerization? This
these concepts are there even. It's not nothing. I mean, this Docker repo was old before Docker came. This is called as your. There's no Docker repo as such. It's just Artifactory was there where you're storing it. So before Docker, it is sorry. Before Docker repo, I think it is also called as forgot the name, but I think it's a repo of your jar files. I mean, jar files is your I forgot the name of that exactly, but I think it's a jar file repo at the end. So you store all your jar files here, right?
So Srini, just to give you an example, right? Like, so if you are going to download some new software, right? Like, let's say you pick maybe just for example, Microsoft's Excel, right? So they put it on a site, right, for download, right? So that is their repo. So that concept has been always there, right? So it is like a FTP site you pull. Now they are calling it repo because it is kind of a repository. Means basically you keep multiple versions out there, and you
Polyglot.
can pick
Now
and
it's
choose.
polyglot also. That is right.
Yeah,
So
yeah. So the concept is the same, but it's just
okay.
that it is enhanced for Dockerization or Docker information. In fact, Artifactory, you can click on a Docker image and see what are all in there, and you can gives you that kind of input or like what do you call inside view of what is in the image.
Oh, okay.
You can open that and see.
Right. Yeah, of course. And for next thing, of course, once you have this your artifacts in place, then probably you should also have a pipeline. Right? So the pipeline could be your
Yeah,
CI/CD setup. So that
but
will
this
actually pull it from this pipeline.
everybody has a pipeline, but if you have Jenkins, people use that, right? It's
Yeah,
kind
yeah,
of that, right?
exactly. Yeah, but Jenkins is one of them. Yes. So you
These guys
create it.
want to make money out of it here. That's it.
Yeah,
If you use this commercial thing, you have to pay.
exactly. And this, I mean, these are all these three are basics that you should have. But beyond that, if you are more worried about security, probably you should have some security scanning tool. So inbuilt security scanning tool, and security scanning is more you're most probably you're using open source tools, right? So it scans your school for any vulnerabilities. So that
Yeah.
so even that
Yeah,
applies even
like
for
I was telling you, right? Yeah, like I was telling you, the latest Kubernetes certification they added on this space only. It's going to be
yes,
a very, very prominent one soon.
exactly. So this primarily scans the images that you uploaded to the repo or artifacts, right? So it will scan that, and also you're also downloading from Maven, right? I mean, for Java Shop, you download your open source libraries in whatever you define in format XML or Gradle file. You will download that from Maven repository or a Gradle repository. So that also has to be scanned. So the libraries that you're using for development, open source development, any Apache or whatever tools that open source tools that you use, so that also has to be scanned for vulnerability, and also the deliverables that you generate from for your application, your custom libraries also has to be scanned. So that is what this scanning tool does. And then next comes your once this, I mean, of course you can also add some additional tools for performance improvement, performance test tools. You can integrate also performance tools can be integrated, code review tools can be integrated, their JUnit unit test tools can be integrated. So these are all additions that anyway you should have it. So I mean, this again comes as part of a pipeline. You can integrate everything in this pipeline. Because
So, has anybody used a Sonar Cube?
yeah, I've used. So,
Okay, so what was that thing doing? Which is coming under code review thing or?
This is code
Sonar,
review.
for Sonar has Artifactory also here and also code review. So I mean, this Sonar product, if you see, it has multiple.
So, is it a static code analysis kind of a thing?
Yes,
Yeah.
static code analysis. So it's primarily for code quality and code review and code security. So
So
basically,
this is also becoming a because of the polyglot thing, right?
hmm,
People wants to make sure after the security scanning, they want to make sure this follow it through on this.
exactly, yeah.
It's the other way around, Penny. So
Ah,
the Sonar Cube is mostly used in development shops.
okay.
So basically, as soon as your code gets done before it goes into production, that's when you do all this checks and then you highlight if there are any critical errors.
Okay.
The security scanning happens no matter what. So it is basically safety gate, the security gate saying this is vulnerable or this is not vulnerable. So
But
that
with
is
the polyglot, will the static code analysis work across the language? Not
no. I
this.
think Sonar is only for Java, maybe C# something, but I don't think anything
No, I
else is
think
there.
a lot of
Maybe I'm.
lot of technologies are added now. So I think the Sonar Cube, I mean, lot of all the popular technologies are introduced now. So it's a multi-language support tool now. So it's right.
Okay.
So it can basically, if you look at this is what it generally gives you it will scans your code, whatever be the technology it is. It will tell you, it will give you a quality gate percentage. So you can set in the pipeline. You can also set what is your quality gate percentage that you want to allow. So if the percentage is below 60% or 80%, whatever quality good that you set. So if the quality is below, it will not even build. It will fail. The pipeline will fail. So that way, developer can know that well in advance when everyone checks in the code. This build pipeline will be triggered and this quality gate will fail. So if it is not meeting the percentage.
So it started with the Java shop, then they added more.
Probably, yeah. I think Java is mostly used, but I'm not very sure. But I think, yeah, I know from Java, but probably others from .NET, whether we have something similar to this SonarQube.
Okay.
Yeah, but yeah, if you look
Java
at
was the
these are the languages that are supported
Java
already.
gives you, because it's bytecodes, right? You can actually look at what is there in there, right? So that it automatically recovers.
Yeah,
Yeah,
C#
27
is
Other
programming
languages,
language.
right? C,
See,
C++.
now it's polyglot.
Yeah,
Even COBOL, man.
yeah,
Mhm.
yeah. So yeah, multi-language support. I mean, Java, Python I use for sure. The C# is also there. Yeah, C++, Go, Swift. Yeah, all the popular languages are there. Right. Okay. Yes, I think this is what it gives you as a summary report. That's all, nothing else. So generally, your pipeline will start with the compilation step. It will do for example, Java, then it will do a Maven clean compiler, Maven clean and stuff. And then of course it will compile and then build. And in this process, it will also check for this code review. So if you have a code review, static code analysis is integrated. So the code analysis tools will generate a report, and also you can create a step, and you also probably can add this in this process first, and then do a build, and also the deploy that completes the CA step, right? The compile, code analysis, and build. So that comes the CA step. So CD step is something that you can see the deployment part. So CD step is where
So looks like the SonarQube is open source, right? Join our open community. So there are two versions, commercial
yeah, they
and
have both. They have both community version and also enterprise version. Both are there. Yeah, the CD step is where you deploy this. You can write some rules here. Well, let's say code analysis report is quality gate is greater than 60% or 80%, then you do the deploy step. So that logic you can write here in this pipeline. So that way it will generate this report, or you can fail the deploy process if it is less than 60. So else fail. So you can write fail the build. So you can write logic like this so that it will fail the build if the quality gate is not passed. So of course, in this process, you can also link. These are all optional components. You can associate this process. You can also include a unit test. These are all optional components. Performance tool test, unit test. These are all optional components. As scanning, security scanning, and all those stuff. So these are all optional components. Okay, I think we got a deroute, but I think it's a good discussion. Okay. Any questions in this before we move to the other topic?
so what is your next topic?
Yeah, my next topic is probably take some other complex application and show that. But probably I think we have less time to deploy it. Probably I will give a go through
Yeah.
of that, and then the deployment part we'll take it in the next session. So
Okay.
yeah, so probably this is. A guestbook which should be interesting to take a look, because this is a multi container application. This, that's follow up. Sorry, this is this one. This is what we saw now. Hello World app. This guestbook is a combination of Redis and PHP. So it is. I think this uses a declarative configuration of YAML based structures. So and this is also a multi-layer component. So there's a front end service. And also there is of course, there's a front end pods for it, and also a leader service, which is primarily for as a Redis based service, which is acting as like a storage, temporary storage. And there is a follower based on Redis on the leader. There's a follower. And the follower also has some pods. So it's basically a front end and a back end, kind of a back end with the Redis as a underlying DB kind of a setup. There's a front end component, and also there's a load balancer at the end. So because it's a front end service, you need to also have of course, a load balancer. And like how we create a service, right? Whenever you are invoking this web application, the request will go to load balancer, and from there the GKE, the Kubernetes engine. So from there, the call will go to front-end service. Front-end service is simple PHP-based application. It's a front-end. PHP is used as the front-end. And sorry, where is that? The PHP reference? Yeah, okay, PHP is okay. So PHP is the front-end, and Redis is the back-end. Yeah, probably I'll just I'll probably show the we'll go through, considering the time is less. Probably let's quickly go through this component so that we get an idea. Then we can move to the deployment part in the next session. So here the requirements at a high level would be to have, of course, these are standards instructions where you want to create a cluster first, which we already created in our case, but the nodes they're looking at 4, not 3. So either if you want the default is, if you remember, the nodes are 3. If you are not giving any requirement, the default nodes are 3. But here, if you have specific requirement to add the nodes as 4, then yeah, I should give this cluster container cluster and num nodes is equal to 4. So this will create 4 nodes. And yeah, this of course, once you create the cluster, you can use this commands like, these are all nothing to do with Kubernetes. I'm just telling these are all Google specific. So will list the clusters, and also it also describes the guestbook, which is nothing but a container command to describe it. So yeah, and then of course this is a sample application where you can download this code also from GitHub. So once you open the console here, you can do a git clone and go to this guestbook example. And then once you do that, this is a deployment Kubernetes instructions are there. This is primarily for deployment of your Redis component, the leader component. So if you look at from what we discussed earlier, right? So there's a deployment, so which means you will have some instructions which talks about your metadata and your spec and how many replicas you need and what is your match labels for the Redis is the label name that we want to give. And also you can add some metadata in terms of labels. These are all free flow. You can type whatever you want in this. But yeah, we want to add metadata labels saying that this app is Redis, and the role it handles is a leader because there's a leader and also there is a follower. Both are there. At any given time, one will be acting as a primary. So that role is there. So that's why we want to deploy an application with a role as a leader. Entire is backend. So and also here the deployment will have a container image. So this is a main section where you need to tell what image you want to deploy. So that is where you are viewing this as Redis as your image, Docker image that you want to download and install. So basically, it is something. It's a. I mean, for people who don't know Redis is just like a internal DB or memory DB in a memory. So where it stores everything in memory. It's like a cache. It's a cache layer where you can store the data in this local memory. It's just a replica of a DB. So DB is permanent, but in Redis it is temporary because once you restart the server, the data in the temporary memory cache is gone. But this is more of a consider this as a temporary DB. So Yeah. So, yeah, but again, the concept is same. Whether you can use Redis as a DB or you can use MySQL also as a DB. But at the end, concept is you need to tell the image name and you need to use the image in the version name. So that is what you need to tell. And you are naming this image as leader. And also you need to give the request resources in terms of CPU memory. Uh, uh, what is this memory that you want to allocate in terms of CPU 100M and memory 100 MI, and also the ports. By default, Redis works on expose on port 6379, so we are going to retain that port. So yeah, so by this deployment, actually you are deploying, when you do this deployment, you're creating a pod with this name as leader. And of course, you're using Redis as your Docker image, and also with this CPU and memory requirements and this port. So this is what it is at the end. Basically, you at the end you will have a Redis uh, running on the node. So that's what you get. So yeah, when you apply it, it will execute this and do a get pods. It will say that this is my pod running, and of course you can go to the logs. Yeah, for any pod. So this pod logs you want to see, kubectl logs is the command. So you can run this and you can see the output. So that's about the leader service. I mean the leader deployment, not service. Deployment is what we created. We just created what is the image and we deployed this Redis image. So that's deployment. Now we need to expose for outside world to call this Redis. We should expose an endpoint, right? So that endpoint is given by a service component. So that's where your service will come in. Here, same thing. What are the same labels that we created above? In the service component, you are telling the default port is this, and target port also is keeping the default, which is 6379 for Redis. And yeah, and then you can, these are the selectors that you want to run. So by this way, if you look at, there is no type that is mentioned here, like load balancer. If you remember in the other places, we have not used load balancer here. So which means the default is a cluster. So cluster is what will be created as our default. Sorry, this cluster IP. So this will be created as a default. So by the way, basically you can access this by creating this service. You can access this Redis on this port 6379. So basically IP colon port, you can now access Redis. That is what the service is giving. So basically deployed and you are exposing the service, so you can now access the Redis. So these two are done. Then when you do a get service, you can see this details about this. The Redis leader, this Kubernetes is the default, and this is now Redis is exposed on 6379, and this is a cluster IP that you get. Basically, you can access now Redis component by this IP colon this port. You can access now Redis. That's about the Redis leader. The next is the Redis follower component, which you saw in this architecture. The Redis follower component is this. The leader is done. Redis follower is this. So we're creating the follower component. The follower component. So only difference is of just this one preference. The name Redis follower and role is follower. And here the replicas that I'm creating is 2. And of course here this is my custom application. Follower is my custom application, not like the here it's a inbuilt, it's a standard image of Redis, but here it's my custom developed application, so which is already hosted in this container registry. So this follower component also follows some CPU memory requirement and it's running on port this. So when you deploy it, you will have this follower component. Since instances are 2, replicas are 2, when you do get pods, the leader, which is we created in the first step, and the followers are 2 instances that are created. So now the backend part is now ready. So now comes the, of course, the service component also associated to this. What we saw is deployment, the service. Again, we are telling to expose this 6379 as the service. So now when you apply service, you see a leader component and a follower component. So now the backend is all done. So we have created the 2 Redis components, follower and the leader and follower is ready. Now we need to go to the front end. So front end is a simple web application developed on PHP. So here also same thing, deployment and service. So here I'm creating a deployment for front end, replicas as 3, and because I want to give the name as guestbook, and the image which I wanted to download is a custom image. Which I developed. So I mean this PHP based application. So and same apply. You here there will be multiple instances that will be generated, but get specifically there will be Redis components and also backend components. I mean Redis component, front-end components both will be there, but you want to filter that. You can use -l command to filter app is equal to guestbook, tire is equal to front-end. So if you are filtering this, it will just only show the front-end components, not the Redis components. So since the replicas instances are 3, so it created 3 components. So far with me. So we created a deployment now. So we also need to create a service component for this. So everything follows a deployment and service. And here we are telling load balancer. Why load balancer? Because this is a front-facing application. So this is a UI layer or front-end layer, right? So this has to be this is a front-end service. So someone should call this from outside. So this UI layer should be coming with load balancer. So here we are creating type as load balancer. But for here, if you remember in the service, we didn't mention any type load balancer. For a backend components, you need to have a type as load balancer. In front-end components, you need to have type as load balancer. Something you need to remember. So going back here, so here, and when you expose the service, here type is equal to load balancer, and the stuff is all the same. And I want to expose this on port 8080. It's at port 80, sorry. And we apply it. So now the front end service is also ready. So now we have an external IP that you can access it. The external is 229 IP, and you can forward by this port 80, which is the default port, and you can access this this output like this front end. But when you type something, when you submit, this will be going and stored in this DB. So yeah, so and then of course you can scale with replicas as 5 from 2 or 3 to 5. You can increase it like this. So you can see output like this. Instead of 3, you have five instances of front end. So yeah, that's all. So basically you have the whatever you type here in this, this will go and store in the backend. Of course, the logic of storing the logic, once you submit it, storing it in this backend, that component will be done in the API call that you call from this the PHP code. So yeah, so at the end that is the overall logic. I mean, you have a simple web application where the front end and there is a back end layer. Back end could be a DB or a simple cache-based services. So yeah, that's probably I think considering the time, probably it will take some time to set up this. Probably we'll do this in the next setup.
Yeah, so same 2 tier 20 years before we all started, new toys now.
yeah. That's right. I think,
That's
but
not happening, right?
oh no,
We
but
keeps getting new toys.
yes. Yeah, but I think the advantages here when the new toys is that you can one command you can create any number of instances. You don't need to manually deploy another instance, right? So one command line will take care of that. Adding replicas.
Whatever the nightmares we followed before, those things are all taken care on this toy.
Yeah.
The next toy will take care of more problems with this one. So that's what happened, right?
Yes.
Sounds good, man. I think it's a good stuff. So we'll break and next week deep dive into this.
Yeah. One last question. So this I was looking at this container security certification, Srini. So it looks like the administrator is a prerequisite for that.
Correct. So before that, I took the CKAD exam. I couldn't pass the exam, but I got pretty close to it. One of the challenge what I faced was, man, it is really time-wise very tough. Okay, so that is the questions are like almost like a 3/4 of a page. Initial questions are simpler, but as it goes, the questions are so involved, and also looks like even though CKAD the curriculum wise is, I have not seen that you should spawn between the master to the control node and so on. But in the real question, so I was not prepared for it. So in the real question, as soon as I saw the question, I started doing it. Towards the last line of the question, they said log in SSH into that node and do all this. I knew it only after the 8th minute. So that is what it is. Looks like what is happening is they are getting some of the questions from CKA because there are some common intersection topics between those three things. So the questions are also kind of hybrid questions. Yeah. So yeah, very good experience though. For example, people who wants to keep in hands-on, I think this is a very good thing. And what you are showing that security exam is the cream of the cake kind of a thing, because it is not just Kubernetes alone. It is Kubernetes plus all the other industry things related to the security along with it. It's very, very nice. Yeah, I want to do it sometime by end of this year or something like that. That's what my plan is. For that, you have to take CKA. And look, what they are saying is they restructured the exams between CKA, CKAD, and this one. Previously, CKA was 3 hours. Now they reduced to 2 hours now. They simplified it now. CKA is more simplified. So what they recommend is take CKA first, then CKAD, then CKS. That's what they are trying to say. But that's fine. Yeah.
Yeah, I think that is. I mean, the CKA may not be a cup of cake, cake for everyone, right? I mean, people who want to be an administrator, then it makes sense. But I think who want to be in developer role,
No. No. It's all you are talking traditional thing, but when it comes to YAMLified Kubernetes, yeah, I think everything matters.
yeah, I understand. I mean, everything matters, but what I say is that it depends on what role you work. I mean, if you're in operation side, this makes sense to do. Of course, you can do it all three. There's no harder rule, but nothing to
Yeah,
stop you. But yeah.
right now I'm in a PGE, right? Uh, our contracts keep extending because of one reason. We are using something called Prisma Cloud, that is the security vulnerability software, and so we are helping them to. You know what? It actually creates thousands of tickets every month across the applications, and somebody has to be on top of it to see where it belongs and those kind of things. That is where I know the importance of this security thing. This is tip of the iceberg, and every industry they have to do this for there are standards for every industry as well. So say for example, machine learning, big data, those are all depends on the use case. But any use case, any vertical, this security has to be done. That's how I see.
Yeah, that's true. I think this hardening is one of the important aspect. Cluster hardening, system hardening, right? So, I mean, this is one of the. I mean, the development from in enterprise, right? The development part looks simple. The at the end, when you go for a deployment, right? So you have to follow so many processes. Ensure that your cluster is hardened, your
You
system
won't,
is hardened.
no, you won't believe it. There are, for example, when you have containers and containers, you actually it's like a peeling onion. You kind of get some container and you do your container or on top of that container and so on. And the Prisma Cloud, the way that gives so many vulnerability, it tells in every layers of it. Some of the layers you don't even have control. What they are saying it is, if you don't have a control on those things, you get that base software, fix all those things, maintain on your side. So it is going to be this space is going to be really interesting and also not easy. And they need more help.
Right. Yeah. I think I was just looking at this landscape. I saw this CNCF landscape. It is growing all around Kubernetes very fast. I mean, just look at, and probably we can discuss this in a separate session more in detail.
Yeah,
But I
next
think,
week we can have a very good discussion around. But I think what very smart move they did,
yeah,
even though Google did not want to make money out of it, they want to give it a neutral place. That's why this came into place, right?
mm,
So cloud native, it has a good name and it has a, but this Linux Academy was there even before all these Kubernetes. So the security certification, they did a smart move. They are putting their own software along with the Kubernetes for
mm.
hardening and everything. So that is how they spread.
Right. Yeah. Yes. I think the security is also like growing. I mean, the security space of Kubernetes is also growing with a lot of ecosystems around just on security and compliance. Uh, but I think there are a lot of database Kubernetes specific databases are also evolving, like which is very interesting to watch. And also
Yeah.
messaging
Yeah,
and
but
yeah, a lot.
see, Kubernetes. See, the problem is Kubernetes evolving in every aspect, but there is one common side is the security. That's what I'm saying. This is where
Mm,
the whole bottleneck going to.
right. Yeah, interesting. So this cloud native space is very interesting. So, but I think if you're not catching up, I think we'll soon be thrown out. I guess. I think. Anyway.
Yeah, yeah.
Mm,
Let's focus our group towards it, and
yeah.
let's focus around the CKAD to CKA to the CKS. Let's see how that goes. As a team, if we motivate, probably we can go. It's not easy though. That's what I could say. After the exam, I'll tell you it is one of the tough exams.
Yeah. That's true. Yeah. Okay, good. Yeah, we run
Okay,
out of time.
sounds good. Yeah,
Yeah,
have a good one. Yeah.
thanks
Bye.
everyone. Thank you. Bye.
Thank you. Bye.
Thank you.